Hello, this lesson is about z-scores. And what do we mean when we say a z-score in statistics? Uh, think of a z-score as a standardized way to, to compare a particular individual to its peers. So that's one way z-scores are used, is to compare individuals um, in a standard way. Let's look at an example. This is from the textbook, chapter 3, problem number 8. It's an example where you want to compare two different students in a standard way. We have two different students who have took different tests, but who did better? So let's read through the problem. It says, in 2010, when she was a high school senior, Alicia scored 670 on her mathematics part of her SAT. Okay, so she did pretty good on the test. The distribution of SAT math scores in 2010 was normal, with a mean 516, standard deviation 116. Okay, now we have another student, John. John took the SAT, excuse me, John took the ACT, it's another standardized test, and scored 26 on the mathematics portion. The SAT math scores for 2010 were normally distributed with a mean of 21.0 and a standard deviation 5.3. So John, he did pretty good on his test too. Now the scoring system is totally different, but if you compare it to the mean of the ACT, excuse me, was 21, and John did above average, 26. Just like Alicia scored above average, because the mean for her group was 516 and she scored 670. But how can we compare these sort of on an apples to apples basis instead of comparing apples to oranges? That's what z-scores is all about. It says find the standardized scores for both students. Assuming that both tests measure the same kind of ability, who had the higher score? All right. Well, first let's make a sketch of this. So let's do the SAT scores over here. In the problem, it says both of these are normally distributed. All right. The mean for the SATs, one more time, was 516. Okay, so 516 goes right there in the middle. And then let's go up 3 standard deviations, go down 3 standard deviations, and the first, let's see, the standard deviation was 116. So we've got 516 plus 116. That gives us 632. Okay. And so on and so on. I'll finish that up in a minute. We don't need to waste time doing all that on the video here. Now, let's take a look at the ACT distribution. So the mean score of the ACT test was 21.0. So that goes right there in the middle. And then let's go 3 standard deviations up, 3 standard deviations down, and the standard deviation for the ACT was 5.3. All right, so let's take this 21.0 plus 5.3, 26.3. Okay, let's fill in the rest of the numbers here. I'll just fast forward this. Okay, I filled in the rest of the values here. So let's take a look at these distributions. So for the SAT, out of all the students who took the test, the mean score was 516 right here, and then standard deviation was I forgot. Hold on a second. The standard deviation was 116. So that's plus 116 plus 116 and so on. Then take the mean minus 160 minus 116, etc. Now let's take a look. Where does Alicia fall in this range right here? So Alicia's score was 670. So 670 lies right about here. Let's use another color here and let's mark Alicia's score. So Alicia's score is right about here, about 670. Alicia's score. All right, which is about, here's the mean. This is 1 standard deviation above the mean. Here's 2 standard deviations above the mean. So it's like 1 point something, about 1.5 or so standard deviations above the mean. Okay, good job, Alicia, on your SAT score. Now, let's take a look at our other person. We have John took the SAT and scored 26 on the math portion. So where does 26 lie on this group? So 21.0 is the mean. So John's score was not quite 1 standard deviation above the mean. It's almost 1 standard deviation above the mean. So there's John's score. Still pretty good. You can see both students scored above average, but Alicia scored more above average, about 1.5 standard deviations above average than John. John did only a little bit less than 1, maybe like 0.9 something standard deviations above the mean. So just by looking at the two populations and where they fall in relation to their peers, we can see that Alicia did better in relation to everyone who took the SAT test than did John in relation to everyone who took this test over here, the ACT test. All right, now this brings us to z-scores. I almost said SAT scores. This brings us to z-scores. Let's turn back to black here. So here's specifically how you can compute a z-score. The formula is z is equal to x, which is the particular score, like Alicia's score, John's score, whoever's measurement, whatever it is you're interested in, minus the mean. And I'll just use this symbol for mean. There's the mu, which you can use as well. I'll just stick with this one for now, which tells you how far above or below average a particular person is, and then divide that by the standard deviation. And that's what standardizes the z-score. So you divide by standard deviation, which tells you how many standard deviations above or below the mean a particular person is. So let's compute the z-score for Alicia. So Alicia's z-score, her particular score in her particular test was 670, I believe. Let's check that here. Yeah, 670 minus the mean, which is 516, divided by standard deviation, which is 116, I believe. Let's double check that here. Yeah, standard deviation 116. All right. Okay, let's do that calculation real quick. And that's going to be 670 minus 516 is 154, which tells us that Alicia's score in terms of points on the SAT test was 154 points above average, divided by 116, which is about 1.32. Now my calculator, it says 1.327586, and the digits keep going. Round off, usually people round off to 2 or 3 digits after the decimal point. So let's go ahead and just round this off. How about just cut it off right there? So about 1.33. Okay, there is Alicia's z-score, which means that Alicia scored 1.33 standard deviations above the mean. Let's write that out here. So Alicia's score is 1.33 standard deviations above the mean. Now, there's no units to z-scores. If your original measurements were in centimeters, the units cancel. So this is a unitless measurement. Think of it like a ratio. How many times greater is Alicia's score in terms of standard deviations greater than the mean? All right, take a minute, hit the pause button, And go ahead and compute John's score for practice, and then I'll tell you the answer in just a moment. Okay, let's go ahead. Hopefully you've had a chance to calculate John's z-score. Now I'll do it here as well so you can see if you're on the right track. So John's z-score, the same formula, x minus x bar over standard deviation. So John's score, let's take a look at the original problem again. He scored 26. And how many points above the mean is that? The mean was 21.0, I believe. Let's double check that here. Yeah, mean was 21.0. Standard deviation 5.3. So divide that by 5.3, and that gives us 5.0 divided by 5.3. So you can see already, if you think of this in terms of a ratio, John's score is a little bit less than one standard deviation above the mean. Now, 5 divided by 5.3 exactly is 0.94, so 0.94, rounded off to 2 digits. Okay, so there's John's z-score. So you can see here, now Alicia's score was 1.33 standard deviations above the mean, whereas John's z-score was 0.94 standard deviations above the mean. So now it's clear that Alicia's z-score is better, so Alicia did better in relation to her peers than did John in relation to his peers. And that is it for z-scores for now.